Hello everyone, this is Professor Robert Solis. Welcome to this next video lesson. We're going to continue talking about the selection structure. So I'm going to go ahead and start a new project, of course, Visual C# and Windows Forms application. So I'm going to title this C#, and we'll say selection structure 2, and we're going to call this the grade calculator. Oops, too many characters. Grade calculator is fine. I'm going to go ahead and click OK. Whoops, let me get rid of that letter C. There we go. And once the form comes up, what I want to do is I want to drag and drop a button labeled text box and allow the user to enter a particular score and then return to them if they got an A, B, D, or F. So let me go ahead and drag a button, a label, and a text box to the form. I'm going to change all of these guys to 12 points. So let's go ahead and go to the font size, type in 12. I'll do the same thing for all of these controls. Go to the font size, type in 12. Okay, good. Now I can take this label, put it up here to the upper left-hand corner, and the text property for this guy is going to be enter a score. I'll put a text box next to that. You see the magenta underline right there. I'll place this button over here, make it a little bit bigger. That looks good. The text property will be submit. And then I need to press a label or place a label down here. I'll just simply take this label, Control C, Control V as in Victor. I'm going to auto size false, border style fixed single. Let me go ahead and resize this. That looks good. That's okay. I don't want the text to be in the upper left-hand corner. So text align is going to be middle center, this guy right here. Now I can get rid of the text. Once I see what it looks like, double click, delete, press enter. Let me go ahead and readjust the size of the form. And that looks about right. And I want to get rid of the minimize and the maximize box. So I'll double click on each of those to make those properties false. Let's get rid of this form 1 text and type in grade calculator. Looks good. Save my work. And the next thing I want to do is to add the names to the various properties. So to the various controls, I should say. So this will be txt score. This will be btn submit. And finally, this will be LBL result. Save my work, and then I'm going to minimize the toolbox and also the properties panel, and I want to enter the code for the submit button, so I'll just simply double click, and now we're in the code area. We're going to type in some comments like declarations, get user input, calculation, and then finally we're going to generate some sort of an output. So I ask myself, what is it that I need to give to the user? What is it that the user gives back to me? And in this case, the user is going to give me a score, and I'm going to give him a message. You got an A, you got a B, so forth and so on. So let me go ahead and double click so I can get back into the code area, and I'm going to create a double called user score. Now the reason why I'm creating a double is it could be that the user gives me a number like 95.5. And a double will handle that, an integer will not. All right, in terms of the string, I'll create an output string, and this is going to be a message back to the user, something like, you got an A, you got a B. That's what the output string will be. All right, so for the user input, we're going to say user score. I'm going to assign something to that. So first, let me convert dot to double. There it is. Parens txt. I don't have to type anymore. Here's the txt score. Let me double click dot text. So what I'm going to do is I'm going to take the text from this text box, convert it to a double, and place that into a variable called user score. In terms of the calculation, let's do this. If the user score is greater than or equal to 90, if in fact that is the case, then the output is going to be the following message. You got an A. Now, if that's not the case, then I'm going to ask else if the user score is greater than or equal to 80, open and close curly braces. If that is the case, then the output is going to be, you got a B. Now, what if that's not the case, that the user got an 80 or above? So I'm going to take this, copy, and paste it, and change this to if the user score is greater than or equal to 70, then you got a C. And I'm going to go over here, Control V as in Victor, paste again. If the user score is greater than or equal to 60, then you got a D. Finally, if all else fails, I'll put an else statement with an open and close curly braces. The output will be you got NF. So what we call this is a multi-way if statement. If this is not true, how about this? If this is not true, how about this? If this is not true, how about this? Finally, if all else fails, then go ahead and perform this else statement. So this is analogous to you having a 1, 2, 3, 4, 5 button radio, and you can only press one of them, and all of the others are ignored. Right? So this is like a mutually exclusive type of deal. You can't have a windy, still day. You can't have a married bachelor. You can't have a wet, dry morning. It's mutually exclusive. Either this is true, or this is true, or this is true, or this is true. And then if all else fails, you do this. But you can't have more than one true option. And so the way that we achieve that is by using this else if statement. So we have if, we can have a bunch of else if statements, and then if you want to, you can have an else statement at the very end. You don't need this. This could have been another else if statement. Like I could have done this and terminated with an else if statement. That's perfectly acceptable in terms of the syntax of how you use an if statement. In this case, I'm using an else at the very end to catch all if everything above is false. So that's what you're doing. You're asking a question, is this true? If not, how about this? And so forth and so on all the way down. If this were true, you will execute this, and then you'll jump out of the code and execute whatever statements I have after this, which in this case, I'm simply going to say the label.text is going to be whatever the output variable is. I'll put that into the text property of the label. All right, so this is a multi-way if statement. Let's see how this works, and then we'll break down the code, see what it looks like when I freeze time. Okay, so the program runs, and let me go ahead and ask a question or answer a score like 99. Okay, you got an A. Good. How about 89? You got a B. How about 89.99999? Now, 89.999 is not greater than or equal to 90, so that'll be false. 89.999 is greater than or equal to 80, so it should say you got a B. And sure enough, you got a B. Okay, how about 79? Looks good. How about 65? Yep, looks good. And then finally, how about 55? So 55. You got an F. Excellent. So our program works. Let's stop the program right here at this if statement. So I'm going to place a break right here. I'll run the program again. I'll enter a score, and let me enter like a worst case scenario, like 55, just so that we can see how we propagate through this if statement. As you can see, user score is 55. Is 55 greater than or equal to 90? No, that's not the case. So let's go ahead and step through this. So did you notice how we completely skipped over this statement, and now we are going to ask a new question. Is the user score, or is 55 greater than or equal to 80? That's still not the case, so we go to the next else if statement. Is 55 greater than or equal to 70? No, so we go to the next else if statement. Is 55 greater than or equal to 60? Nope. Well, since everything above is false, we are going to execute the else statement, which, as you can see, is assign this string, you got an F, to the output variable. So let me go ahead and click continue, and you can see that the string is placed within this label. Let me take off this break so you can see that you execute this first, then second, third, fourth, and then finally, if everything else above is false, you execute this. Now you'll notice the strategy of me asking if the user score is greater than or equal to 90, then 80, then 70. So you see definitely a descending order to my values. And there's a logical reason for that. Now, I don't want you to do this. This is just part of an experiment, but let me take this, cut it. I'm going to place it over here, paste, and then I'm going to change this to an else statement, and I'm going to change this to an if statement. Now, why didn't I do it this way? Well, let's see what happens. So let me run the program, and I'm going to enter a 99. That should be an A, but it says you got a B. Why is that? All right. The reason why is the ordering of my if statement has to make logical sense. Notice over here I say if user score is greater than or equal to 80, then you get a B. Now, that's true for 80, 81, 82, all the way up to 89.99999, so forth and so on, right? If it's 80 something, then I got a B. But since this is my first if statement, if the user enters 99, which is what I just entered, 99 is in fact greater than or equal to 80. And so that means that this is a true statement. And if this is a true statement, then you got a B is assigned to the output variable. So this is what we refer to as logical errors. Logical errors are dangerous. Syntactical errors, like forgetting to put a semicolon or something like that, those are easy to fix. You get a red squiggly underline, you realize, oh, I forgot to put a semicolon, or I misspelled something. Those are easy types of errors, syntactical errors. But logical errors, those are tough to fix. And if they propagate throughout your program development cycle, that can lead to some big problems down the line. So you want to make sure that logically your program has been well thought out and planned out. The problem in this case is I am asking the wrong question first. I should have asked this question first, which is the user score greater than or equal to 90? Because if that's not the case, then I can ask if the user score is greater than or equal to 80. So let me go back to what I had before, which was this situation over here. If the user score is greater than or equal to 90, let's say that that's false. Well, that means that we would jump over here. Now, when you're asking this question, you're really asking this question knowing that the above is false. So really what this is if the user score is greater than or equal to 80, and we know that it has to be less than 90. Because if it was 90, this would have been true. But since this is false, the user score has to be less than 90. It can't even be equal to it, because over here, this is user score greater than or equal to 90. But if this is a false statement, then the user score can't even be 90. It has to be less than 90. So really what this is asking the question, is the user score greater than or equal to 80? And we know that it has to be less than 90. And that's why you see this strategy of asking questions via these if statements in descending order. Could I have done this the other way around and put something in ascending order? Sure. I mean, case by case scenario. I think the driving fact of having it in a descending order, in this case, it looks logical. You can take this and assume that the above is false. You can take this and assume, not actually assume, you know that the above is false if actually you're at this level. We know that the user score is greater than or equal to 70, possibly greater than or equal to 70, but we know for a fact that it can't be equal to 80. It's got to be less than 80 if you're asking this question. If you're asking this question, then we are determining if the user score is greater than or equal to 60, but we know it can't be equal to 70 because otherwise this would have been the true part. And then finally, if you reach this else statement, we know that everything above is false, that the user score is not even greater than or equal to 60. It must be less than 60, which means that you got an F. That's how I want you to think about this multi-way if statement. Very powerful because it gives you all kinds of options. Let me also show you something else. If you just have one line of code after an if statement, then technically speaking, you don't need these curly braces. And so some programmers like to do this. They'll take off the curly braces since they only have one line of code, and then it makes the code look a little bit more optimized, I suppose. Or let me just get rid of these spaces. It just looks like it doesn't take as many lines, so I'll do this over here, do this over here. So you can see as I'm getting rid of these empty lines, the code looks a little bit more compact, perhaps maybe even a little bit easier to read. Whoops, I don't want to do that. Right there is fine. So if it's just one line after the code, after an if statement, I should say, then you don't need the curly braces. Now, personally, I enter the curly braces because rarely do I have just one line of code after a given if statement. Typically, it's several lines of code. So if you have 2 or more lines of code, then you've got to incorporate the curly braces. So let me put those back. If you're going to have 2 lines of code underneath a given if statement or else if statement or else statement, then you have to have these curly braces. So I just typed them out of habit, but I wanted you to know that technically speaking, if it's just one line after an if, else if, or else statement, you don't have to have the curly braces. And that is it. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.